Alright everybody, I wanted to make a little video on looking at the trig properties on how to transform one function to another. So I'll put this up for a second. You can pause it, copy it down, reference it, whatever you need to do. But these are a bunch of identities that will always be true that we're going to use to transform one function into another. So here's your reference page, your cheat sheet, whatever you want to call it. Here we go. Let's do a few examples. All right, transform. We want to take the thing on the left side and turn it into the thing on the right side. So there's not a one size fits all. You gotta just practice and kind of get experience. But one thing I see is the left side has a lot of terms and the right side only has one term, cosecant squared. So what I'm going to do is start by distributing and just see what happens, see if I can cancel something out. So if I distribute the cosine into this, I end up with something like this. And cosine times secant, remember secant's 1 over cosine. And this is a reciprocal property, and this thing actually becomes 1. And cosecant squared, I'm not a big fan of that. But cosecant is the same as 1 over sine squared. And cosine over sine is cotangent. And the Pythagorean identity, if I go back real quick, we got cotangent plus 1 is cosecant. That's going to be cosecant squared. And I did the transformation. Sweet, it only took 2 minutes. Here we go. Next one. Transform cosine squared minus sine squared to 1 minus 2 sine squared. So sometimes it's hard to get started, and when I look at the goal, right, this is what we're trying to get. I notice that there's a sine squared in it, but there's no cosine squared. And so it kind of gives us a little bit of a hint. I'm going to leave this alone, and I'm going to mess with this one. So one thing that you want to kind of get comfortable with, because it comes up a ton, is this is the bread and butter. But I could also say that cosine squared is 1 minus sine squared. I just move this over here by subtracting. So I can replace this with a 1 minus sine squared. And then this one is just chilling. So now I have 1. It's kind of weird because it's new, but combined like terms, I have minus 2 sine squared. And now I'm done, because that was the goal. It's all about choosing wisely, so to speak. Again, practice it. All right, example 3 on our journey. I mix up the colors a little bit. All right, here we go. I need a tangent and a sine, and I got none of that going on. But I'm going to try a little math, a little algebra. So when you have that squared, it's saying I'm going to take this thing and actually square it. So one strategy is to perform the algebra that's suggested. So if I do FOIL, multiplication, box method, however you learned it, I've got cosine squared minus cosine theta secant theta minus secant theta cosine theta, and the last one plus secant squared theta. So now I've got cosine squared theta minus 2 cosine theta secant theta. I miscopied this. It should be a secant. Plus secant theta squared. And remember, these guys are reciprocals. Maybe you don't remember. I'll prove it to you right here. Cosine times secant is 1. So now I have cosine squared theta minus 2 times 1 plus secant squared theta. All right, here's where it gets a little bit weird. It's about as hard as it gets, but if I do like a cosine squared theta minus 1 plus secant squared theta minus 1. Right, I've kind of got these two things going on. And I go back here. Anytime you have a squared function, you want to think about these things called Pythagorean identities. And for instance, you could take this one and think of it as, cosine squared theta, or x, minus 1, equals negative sine squared x. Kind of like we're manipulating. What I have here is I have that. This becomes negative sine squared theta. It doesn't matter if it's theta or if it's x or if it's a or b, just the variable that's going along with it. And now I think I'm onto something because I have this, and that's part of my goal. So if I look at the second one, secant squared minus 1, and I go back to this page, right here, if I subtract 1 from both sides, I get tangent squared is equal to secant squared minus 1. Ooh. So secant squared minus 1 is tangent. So this is tangent. And now I have to work on my color combinations. I have my goal. This is about as hard as it gets. Thank you for watching. All right, let's do one more. All right, transform 1 minus cosine squared x over tangent x into sine cosine. All right. So a little trickier here. You have a couple options, but I will say anytime you see something with a square, sine squared, cosine squared, tangent squared, whatever you see, you want to be thinking about the Pythagorean identities. That's these guys that are in the box. You're only going to use those when you have a square term. So when I think about this numerator, 1 minus cosine squared, the go-to with cosine is I have that, sine squared plus cosine squared is 1. You do want to memorize this. And if I rewrite this, I could say that sine squared is equal to 1 minus cosine squared. Right? That's me moving this to the other side. And so what this becomes is the numerator becomes a sine squared. And you know what? It's experience has let me do it, but I want to somehow get a sign in there because there's a sign in the goal. You want to convert stuff to try to make the goal show up. So another way to think about this, again, now I kind of have a sign there, but I need to have a cosine in there also. One way I could write the numerator is this. And again, I don't see it right away, but I do know that tangent is sine over cosine. And so now I have this big mess here, but if you think about it for a second, I have cosine, I got a cosine in there, I got a sine, I got too many sines. So I want to be careful with my algebra here. But remember that when you have a complex fraction, meaning a fraction in a fraction, I could write this as the numerator times the reciprocal of the denominator. Right? When you have 1/3 divided by 1/2, you could write it as 1/3 times 2 over 1. That's an algebraic rule. And when I rewrite this like that, oh baby, here we go. One of my signs goes away. And I'm left with sine times cosine, which was the goal. So a little bit weird. Try to keep it short. You got a few examples to reference. Check them out. Thank you for watching. Good luck, and I'll talk to you soon.